each and everyone to this second edition of we welcome you. Good day everyone. Today we'll be looking at calculations of what transformers, and transformer is one of the important device in electrical circuits, and we have a question here that we need to solve. So let's see what the question is telling us to do. That's our example 1. So the example 1 is telling us that the maximum flux density in the core of 250 stroke 3000 volts 50 Hz single phase transformer is 1.2 Webers per meter square. If the EMF per turns is 8 volts, determine the primary and the secondary turns. Second, determine the area of the core. So this is a question, and it's telling us that the maximum flux density in the core of a 250 and a 3000 volt 50 Hz single phase transformer is 1.2 Webers per meter square. And then the EMF per turns is 8 volts. That means the EMF in both windings, that's the primary windings and then the secondary windings. Good. So now let's try to create our data, which is what we have in our question. The first one is the voltage at the primary, which is the 250 over here. Good. And let's try to write for second voltage at which is the voltage at the secondary. That's 3000. And it says in the question we have EMF of 8 volts, which is per turns for the secondary and the primary windings, and we have a frequency of 50 Hz. And the question is telling us to determine the primary and the secondary turns, and then to determine the area of the core. So we don't have these three things. That's what you are going to find. Okay, so whilst we are starting to find the number of turns in the primary and the secondary, we have to check. In the question was stated that the EMF per turns is 8 volts. Okay, so the EMF divided by the number of turns will give you the 8 volts, which is the EMF per turns. The EMF over turns is equal to 8 volts in both sides. Good. So now let's take the formula for calculating the number of turns. So the number of turns is for the primary is the voltage of the primary divided by the EMF per turns. That will let us know that there is a number of turns the windings were wound. Okay, so that will give us the 250 divided by the EMF per turns, which will give us 31.25. Okay, 31.25, and this is a turn. So we'll pick the nearest whole number to make it 32 turns. Okay, good. So let's do for the secondary also. So the same thing that we did for the primary, we'll do the same thing for the secondary also. So we'll state the formula by N is equal to V2 over EMF per turns. So which is the voltage of the secondary windings divided by the EMF per turns, which is 3000 divided by 8. That will give us 375 turns. Very simple like that. Good. So let's continue. The II states that we should determine the area of the core. The area of the core. And we know that for EMF per turns was given already in the question, which is what? 8. So we have to state the formula for finding the what? The EMF. Okay, the EMF. So we know that the formula for EMF is what? 4.44 times the frequency times the flux. Okay, so now we have the EMF per turns, but we don't have the flux. What we have in the question is what? Flux density. Okay, the flux density. So let's continue. So now let's try to make the flux the subject. Okay, so when we make the flux the subject, flux is going to be what? EMF per turns all over what? 4.44 times the what? The frequency. Okay, so you put in the values. The EMF per turns is what? 8. The 4.44 is what? Constant. Then times the what? The F, which is what? 50. And that will give you what? 0.036036 Webers. That's for the flux. Now that we have the flux, we are finding for the what? The area of the core. So you have to what? Find a suitable formula that will help us find the area. Very simple. So we have flux is equal to flux density times the what? The area. So what we have to do is what? To make the area what? The subject. Okay, the area, the subject, which is equal to what? The flux over what? Flux density. Okay, good. And we know that in the question the flux density was already given. That's 1.2 Webers per meter square. Okay, good. So put that in the equation, which will give us 0.036036 divided by 1.2. That's what we have here, which is equal to what? 0.03003 meter square. Okay, so let's try to write it in a simpler form, which is area of the core is what? Equal to what? 0.303 meter square. So that is the area of what? This windings or this transformer. Okay.